vertical axis of revolution. We are still, so vertical line. We talk about vertical axis of revolution, so things that, other lines that are parallel to the y-axis, which means these problems, since it's lines parallel to the y-axis, will be worked in terms of y. Okay. You're still going to think in terms of big R and little r. So r squared, big R squared minus little r squared. We're going to talk about them as being as functions of y and integrating along the y-axis. So kind of like what we started off with yesterday, we're going to look at just general setups, and then we'll go into some specific examples. So write the general form of the volume for the area R, where any cross-section is perpendicular to the axis of revolution. Okay. So we are rotating here about that x equals c. And I guess let's talk about big R. I'm trying to think how we did this yesterday.
The line of C to the y-axis.
Okay. So this line here, all the way over to the farthest most distance. Okay. So big R is going to be the distance when where you're rotating about, and the farthest most distance, which in this case, this is x equals 0, right? Mm-hmm. And so for big R, this is going to be c minus 0, or in other words, it's a distance of c. Okay, what about little r?
From the curved line to
Okay, curved line to our axis of revolution. I keep forgetting to label these. There's little r. That's big R. Now, instead of talking about these as f of x functions, because we're going to need things solved in terms of y, we're going to talk about these as f of y functions. And so little r is the distance between f of y and c, but we're going to do c minus f of y. And like yesterday, it was more upper minus lower, yes? Today, it's going to be more right minus left. And I think we're ready to write, aren't we?
Yes.
Volume equals?
Pi.
C squared minus C quantity C minus.
Okay, so pi times the integral from a to b. Then brackets is usually a good way to go. Big R squared, so that's c squared, minus little r squared, so c minus fy, quantity squared, and then dy. Okay, next one. This time, x equals c. So here is our rotation line. What about big R?
From the curve to x equals C.
Okay, so from the curve to x equals c. And so when we talk about big R, how are you writing that? What?
Fy minus C, or are you doing it plus instead?
Okay, so
Like minus a negative.
minus a negative. So it turns into a plus. Okay, and here's the deal. Because again, it's to the left, thinking it's going to be a negative value. Okay, so f of y minus negative c is what I'm going to write. Okay, little r.
C.
Okay, That was big R. So little r is the distance from x equals c and x equals 0.
So it's 0 minus negative c, which is c.
Okay, so think 0 minus negative c, which is a distance of c. Volume equals.
Phi times integral of a b.
Okay. F of y minus negative c, or plus c, quantity squared, minus c squared times dy. Okay. What changes up on the bottom ones?
It's whole. No, it's washer.
Well, technically the others were washer too.
Those are washer too?
Yeah.
The whole, we only do washer.
Oh my gosh. What am I doing?
We haven't done that.
Especially what are you doing? Whatever you're doing, do it.
The difference is that they're instead of one of our edges being the y-axis, we've got two functions. We got f of y and a g of y, which they have labeled for us. Okay, so here is our axis of revolution. Yes. Okay. Big R.
2x x equals
Okay, so there's your bigger distance. And when we write that, how are we going to write that?
G of y. Or c minus g of y.
C minus g of y. What about little r?
c minus f of y.
C minus f of y, and that is the distance from the closer edge to the rotation axis. So V equals pi times the integral from a to b.
C minus g of y squared minus c minus
With what feels like a bazillion parentheses in this one.
Yeah.
Just because the f of y's, f of y and g of y have parentheses. Then you've got parentheses for the squares. Then you've got what I use as brackets for the whole big thing. Okay, one more. Okay. X equals c is over here for rotation purposes. I will say half the battle in these pictures is looking at how she has it set up. Where, which axis are we rotating about?
On the second one, I was like, wait a second, that's a distance. I was very confused.
Until you realize where
And I was like, oh.
Yeah, where the rotation, where you're, and that's part of the reason, as silly as it sounds, but it's helpful to sometimes have that visual reminder. My silly little arrow gives that visual reminder of, okay, this is where I'm rotating. Okay, big R?
F of y to c.
I didn't label them. Hopefully you guys know big R.
To label mine too. I think
Probably because I'm not labeling mine.
I
Okay,
do it like after like, oh,
the big R, what are we doing?
It was just a
minus plus c.
function of the
Minus negative c.
Big R is f of y minus negative c, because c is a negative value again. Little r?
gy plus.
It's going to be g of y minus negative c.
G of y plus c.
I'm done with these things. Oh shoot.
They're that ready for the calculator problem. Okay, pi times the integral from a to b of big R squared minus little r squared dy. Okay, we got the basics, yes?
If that's all homework was, I'll be golden. Yeah, pretty much.
We gotta do the actual set. It is kind of in a way all homework is, but you have to do the setup. Okay, do I have example 5 on the next page? I do. Okay, guys. Find the volume approximation of the solid generated by revolving the region bounded by y equals the cube root of x, the x-axis, in the line x equals 1, about the line x equals 2.
Sure.
She didn't give me an axis. What?
I
So
see.
the calculator first. What a meaning.
Wait, so
Well, okay.
That's what I thought at least.
What?
I thought that's why we had the calculator part.
Yes and no. I mean, yes, you can, but I think it's going to be hard getting the visual. I don't know. Because, like, for instance, you can't graph the line x equals 1 or x equals 2. Okay? You know, our calculator has to be y equals, so you can't graph these vertical lines. So, I don't know. For my benefit, for my teaching purposes, we're doing a picture by hand. Now, if you're using the calculator to get your ideas, whatever, so be it.
cube root is a
It's
cube
like
laid
weird
down, right?
S.
Sideways cubic, right? Y equals x cubed is up. Y equals cube root of x is the sideways. And I'm not sure if I'm drawing that right or not. But so now, based on everything it's saying, realize, okay, so it's coming from over here, yes? And then doing this,
Yeah, that's right.
okay? I just know enough to know that we don't need this stuff over here. You know, focused on first quadrant. So there's y equals the cube root of x. Okay. Y equals cube root of x. The x-axis, which is down here, right? And x equals 1. So x equals 1 is that, yes? Arbitrary, you know, piece. So this right here is the region in question. Yes? And what are we doing with this?
Rotate around.
The line x equals 2, which is some line over here. Maybe I should have made that solid line. Why did I make that dotted line? I don't know. Okay. Now, let's see. Some talking points. Big R, little r, I guess.
Big R is 2 minus the cube root of x.
Yes and no.
I feel like little r is the one.
What is that? Oh, it's sideways.
I agree this is R.
Yes.
Yes? Okay. I agree that it's 2 minus something.
2 minus y? Or, no, 2 minus y cubed.
We're rotating around what type of axis? A vertical axis that looks like a y-axis. So what do we need to work in terms of? Y's.
Very.
They gave us y equals cube root of x because that's the typical name of the equation. That's how you can visualize the graph. What is this if we solve it?
X equals y cubed.
You cube both sides, it's x equals y cubed, yes? So now, so that means big R is our C value, which is 2, minus f of y, if you will, but f of y is going to be y cubed. Are we there?
Yeah.
Okay. That's why I wasn't saying Doug was totally wrong when he said 2 minus cube root of x. But I needed it in a different form. What about little r?
Minus 1, which is
2 minus 1? It is 2 minus 1. Can you go ahead and say that's 1? You can if you want. That's fine. Okay, you can leave it as 2 minus 1. We're going to need a little bit more information.
We need to
Zero
do
bounds.
We need to talk bounds.
0.
0 to 1.
Now, what are our bounds in terms of?
Y.
Y. So, this is a 0. What do we need to confirm?
Oh,
That is
That
1.
piece.
And
Is this 1 or were you grabbing this one?
I was grabbing the Y1 because the cube root of 1 is 1.
So if we put 1 in here, the cube root of 1 is 1, agreed? So is this ordered pair 1, 1? It is. But realize we're grabbing the Y value 1. Fair enough? Okay. I feel like I have to clarify that because when it's 1, 1,
Why do they do that to us? Why don't they?
I know. I was guessing most of you were grabbing not the Y value. Okay, volume is
5 times n log 0.
okay.
2 minus y cubed 20 squared minus 1 squared.
Okay. Do I get it? Pi times the integral from 0 to 1 of 2 minus y cubed quantity squared minus 2 minus 1 or 1 squared dy. Now, officially it says calculator, yes? I wouldn't worry about squaring this out none if it says calculator. Okay, about the only thing I would do is drop off the square off the 1 here, but pi times the integral from 0 to 1 of 2 minus y cubed squared minus 1 dy. Now, keep in mind, yours is going to be in terms of x, right? Because you just automatically punch in x's to the calculators, but it's fine.
6.732.
Doug,
6.732.
it's 1732.
Dude, just did
Why? What is wrong? 6.732.
Or 1.9. This is 6.732. You can put 1.9. Did you put your pi out front, Sophie?
I'm doing that. It was a sin.
Oh, okay.
Sorry.
So it's not that you
Yeah.
definitely mistyped something. It's a matter of what.
Yeah. I had 236.
That was going to be one of my guesses. It was a parenthesis issue. Okay, you got the basics there, yes? Okay.
It's cold.
No calculator symbol here.
Yeah.
Behave. Okay.
Silly.
What do we know? Okay, y equals x squared is a parabola.
Oh.
Now, I don't know if you guys saw me pausing for a moment as I was drawing my parabola. Technically, as you draw this parabola, you need to kind of figure out, is it going to cross over, what line is this over here that's represent, you kind of have to figure that out. But the line I was drawing in there, I had to pause for a moment. But okay, so y equals x squared. I did draw the whole parabola here, notice. And it does kind of end up making a difference. But we have y equals x squared. Y equals 4, which y equals 4, what's y equals 4 doing?
Line up.
Like up there, yeah.
It's up here, right?
Took the line.
And it's basically telling me how high up we're going on this parabola, right? And that's about the line
No, it's fine.
x equals 3. So what is it that we are rotating?
About
About x equals 3, which is what she has in as that dotted line. There's nothing that says first quadrant only or anything like that, which is why we have to take the whole shape with us. Okay? Now, if they had also thrown in x equals 0 as a boundary, then we could just talk first quadrant. They didn't do that. Okay? Okay. With this in mind, we need some, what, big R, little r action happening?
Would the outer radius just be the outer part of the parabola? And then the inner radius is the one that's closer to the line?
I think so. I'm trying to figure out exactly what you meant, but
Outer radius is the one on that side, in quadrant 2. Yeah.
so right here, there's my big R, yes?
Your little r is closest
Little r.
is from
Is
that
right
line
there,
out
yeah.
there.
It's kind of weird, isn't it?
It is.
Because it's the same curve in both places. But, okay. With this all in mind, okay, thoughts? Outer or big R?
3 minus first y.
Negative.
Okay. So 3 minus vertical axis. What do we need to be in terms of?
Y.
Y's. What'd they give me?
No,
Well, they gave me y equals x squared because that's the easiest way to picture the graph. But what do you know about y equals x squared?
x equals square root of y.
Officially, plus or minus the square root of y. Does that matter?
Yes.
It does.
It's really negative.
So what is this over here in quadrant 2?
3 plus square, because it's the negative square root of y.
So this graph, this side is x equals negative square root of y over here. What is in quadrant 1? X equals positive square root of y. That's going to matter in your setup. Because if you do this setup wrong, everything's going to cancel. And you're going to get 0, which isn't going to, not really going to work. Okay, so my outer radius is going to be what I'm going to write as 3 minus
Pablo, please return to Miss J's room. Pablo, please return to Miss J's room. Thank you.
3 minus negative square root of y, which does clean up to be 3 plus square root of y. Okay, what about inner radius then?
3 minus square.
Okay. It's going to be 3 minus the positive square root of y. And again, if you do these both the same, they're all going to cancel and we have an issue. Method? Well, it wouldn't have to be, but I think all the examples that we talk about are. We're not. Okay. Let's do some setup. Oh, I know what we haven't talked about.
0 to 4. For bounds.
Yes? No? It's in terms of y, so 0 to 4. Okay? So big R squared, 3 plus square root of y squared, minus a little r squared, 3 minus square root of y squared, dy. No calculator, so as I said, what are we doing?
Squaring everything out.
FOIL. 3 times 3 is
9.
9. 3 times square root of y.
3 square root
3
of
square
y.
root of y.
Another 3 square root of y is going to make it 6 square root of y. And then square root of y times square root of y?
Plus
Y.
Y. Now, minus, I'm going to go ahead and put parentheses, just I'll subtract here in a moment. 3 squared,
9.
9. 3 times minus square root of y.
Minus 6 square root of y.
Yeah, minus 3 and minus 3 is going to be minus 6 square root of y.
Minus y.
Minus square root of y times minus square root of y
Plus y.
plus y, because I'm in the parentheses, times dy. I'm going to do one more cleanup. Pi times the integral from 0 to 4. Okay, 9 minus 9.
0.
Gone. 6 square root of y
Plus
minus negative 6 square root of y is going to be
Plus 12 6 squared.
12 square root of y or 12y to the 1/2?
Oh, yeah.
Because I'm getting ready for my next step. Y
Why?
minus y
Cancels.
cancels.
W. No, one grade.
Did that really clean up to just be that? It did. Nice. Okay.
I times 8 over. No, is it 8?
Well, it works out to just be 8, yeah.
Or 8 yeah.
There's a pi. The 12 times 2/3
8.
is 8. So you're going to have 8 pi out front when you clean that up. And then we're going to evaluate. So square root of 4 cubed
8.
minus
0. 60.
Okay. Next problem?
Yeah.
Okay. Y equals 2 square root of x. Y equals x about the line x equals negative 2. Let me get this out of the way. Okay. 2 square root of x. Square root of x. Square root of x. Right? What's multiplying by 2 do to it?
Stretch.
Stretches it up a little bit. So basically, if this is square root of x, 2 square root of x is that. Does that make sense? I'm not putting both of these on there. I'm just giving you a visual. So basically, it just goes up a little higher.
Just a high.
Y equals X.
That's the. Just,
What is y equals x?
The line.
Perfect diagonal line.
Oh.
Did you get that from the?
No, but I realized when she said it. 'Cause
Y equals x is that. Now, if you're not sure how these go in relation to each other, you have to do a little thinking. Okay? So, what is it that we're rotating? That little sliver? Mine's a little sliver at least.
Mine's one.
Okay? Big R, little r, method, and bounds.
Little r is from r to the curve. Line to the curve.
Okay? As in,
There.
you said little r, yes?
Yeah.
Okay. Anna starting us on little r.
Big
Big R is
from the line to the
from the line to the line. I know what she means.
describing is not easy.
Well, officially we should say from x equals negative 2 to y equals x. You know,
Oh.
that's, that would be official if you want to,
You know, I didn't think to do that.
Oh, that's wrong.
there's 7 of us in the room. As long as we're understanding. But yeah, official lingo. Okay, so big R. What are we going to do with big R?
Square root of 2. No.
It's y plus 2.
Yeah.
Because it's y equals x, which is x equals y, right?
There we go.
And so then if you're doing y minus negative 2 is what I'm going to write there for the moment. But yes, by all means use y plus 2. Okay, inner radius.
Y squared over 4 minus negative 2.
Huh?
Yeah, because I
Okay. So what do you have to do first here?
changed
Divide.
it.
We're going to have to solve this, yes? So if we divide by 2, this is y over 2 equals square root of x.
Square root of 7.
And then you're going to square both sides. So x is going to be y squared over 4.
I'm there now.
1/4.
Okay? Y squared over 4, 1/4 y squared, whatever floats your boat. So when we subtract these, y squared over 4 minus negative 2.
We need our bounds.
We do need our bounds.
Zero is gonna be one of them.
Yeah.
0, 0. And then we need to know how high this goes. So,
So they make them each other.
yeah, basically, and we really technically only need the y boundary, yes? But here's the deal, it's y equals x. Aren't my x's and y's going to be the same? I personally, I don't know, my gut went to setting x equal to 2 square root of x.
That's just.
That was smart.
But could you also set up the other way? You can. Although it's going to end up similar, so. Okay, if I, what do you want to do here? Square both sides?
Yep.
So then you have x squared equals 4x. Set equal to 0. X squared minus 4x equals 0. You can factor. And this is saying there's two solutions, right? 0 and 4. Well, duh, there's two solutions. The curves intersect right here and here, which is going to be what? 4, 4. I know it's 4, 4 because it was y equals, on the line y equals x. Okay, and method, whatever a whoosher is. Okay. Set it up. And do realize when we say 0 to 4, it's the y value 0 to 4. Again, I'm specifying so you get that practice. Okay. Big R squared minus little r squared dy. Calculator symbol? No. I think the next page has calculators though, yep. Okay, so let's do some cleanup. I'm not ready to integrate yet. Y plus 2 squared, that one's not bad. Y squared plus 4y plus 4. I'm going to say minus, I'm going to put this next piece in parentheses. If you want to go ahead and change your signs as you go, more power to you. Y squared over 4 times y squared over 4.
Y to the 4th over 16.
Y to the 4th over 16. Y squared over 4 times 2. So if you think about that 2 over 4, it's going to become 1/2. And then that's your outsides. You're going to end up with 1/2 y squared plus 1/2 y squared, which is just going to be a y squared. And then last, plus 4. Okay. If you want to go in order, I'm going to say minus y to the 4th over 16. I'm just going highest to lowest here. I think you just have two terms, right?
Fours cancel, y squares cancel.
Yeah. Negative. I have negative 1/16 y to the 4th in my notes, plus 4y. Okay. Add 1 to the power. Divide by that new power.
So 1, no. Yeah, 1 over 16 times 5, right?
16 times 5, yes. Which is a good math fact to know. It comes up more than you'd expect. Okay, so I have negative y to the 5th over 80 plus 2y squared. Or my notes, yeah. I don't know why I'm doing it over 80 today instead of 1/80th, but, you know, it's good practice, right? Doesn't matter. Ugh, I don't know 4 to the 5th. Whatever 256 times 4 is. 1,024 over 80. So my zeros to myself, or if nothing else, just the visual to myself that, okay, I did check. They are going to be zeros.
Could I leave my answer like this? If I'm like at this point, I'm like, I just.
Okay, so here's a good question. If you're on multiple choice,
No.
probably not. If for some reason you have something like this on a free response, that is equivalent to the final answer. So yes, you could have stopped and said that. Because you've plugged in your numbers. You can stop at any point after you plug in the numbers.
Baller. I'm gonna forget that.
That's the thing. It's so out of our norm.
Oh, I was about to say.
Oh no, if I can't do it anymore, I'm leaving.
Yeah, at that point it's calculated.
Like, I would have probably left.
You know what? That could reduce though, couldn't it?
I don't.
Well,
It can.
Yeah.
By 2, at the least 2.
exactly, at least by 2, as I'm getting a common denominator of 80.
Yeah.
I thought like 4.
What about 4?
It could go 4. Could definitely go by 4.
I would have left it.
It could go by 16.
The fit.
Oh my gosh.
It's nice to have to.
It's fine.
And
I'm just
that was meant to
Oh,
give
okay.
it.
Are you saying you wanted me to reduce?
No, it was a joke.
Oh gosh. I may regret that. Which did I reduce in my notes? I reduced in my notes big time. Oh boy.
It's fine, this was fun. And this isn't a calculator.
No, because if we were reduced, life would have been better. But I didn't see the reducing, so life isn't better.
That's fair.
I mean, I'm just doing what you guys do, right?
1,556.
That's assuming I didn't make a mistake anywhere else.
That's what I got.
But here's the deal. Okay, is that technically a good answer?
Good enough for me.
It is. Earlier I said that we said, okay, they minimum divide by 2. Then someone threw out 4. And then I realized 16. So-
96 over 5 is what it reduced with that 96%.
Yeah, I knew it reduces something over 5. So, yep.
Sorry, I cheated.
No, that's all right.
That's tremendous.
I know as a calc teacher, I'm supposed to say, stop here. You can do that. Okay, that's legal. But, oh my gosh, it's so against everything and anything else we've ever done, right?
Every
It's
inch
against
of
the
your house.
I will say, teaching calc has given me a different view on reducing fractions like back in Algebra 2 and pre-calc. I'm not quite as strict on it as I used to be. I mean, I still expect it, but when it comes to like grading quizzes and tests, I'm not quite as strict as I used to be.
With Doc, like for
So-
ACCAM, we started doing pH, and he told us, he's like, yeah, these sig figs don't matter as much, and we all kind of looked around like, maybe he's just kidding with us. He wasn't kidding.
Okay, guys. This is kind of our mixed page, isn't it? I just realized. Okay.
It's
And I say mixed page because,
This is
what is this? A horizontal line. Now we're going back to yesterday's half of the lesson, yes? So that's line y equals 1. X equals e to the y. Why? Ugh. Okay.
natural log of
Well, it's a natural log, yeah. X equals e to the y. Here's what my brain did. My brain says, okay, it's the inverse of y equals e to the x. Okay? The inverse of y equals e to the x is the natural log. Okay? Regardless, can you just plug this into your calculator and graph it?
Yes.
we can.
How?
No, you can't, because it's.
I was about to say.
Exactly. There's the problem. So, how about a little left, right, middle? So if we do left, right, middle to get that y out of there, this is going to be log base e, right, which is natural log of x equals y. And I don't know why I wrote the base e, but I figured you guys might need a little log review because you've slept a lot since then, right? So
Is
y
that
equals,
what she's doing right
last chapter.
Oh, dirty.
Okay, y equals natural log of x is a graph like this. Your Now, the key here is we also have x equals 1. And again, if you're graphing this on the calculator, perfectly good. Okay? X equals 1, well, guess what? Natural log of x crosses the graph right here at where?
X equals 1.
At x equals 1. So x equals 1 is that line right there. Y equals 1 is this line right here, yes? And what are we rotating about? Y equals 1. Are you catching this?
Yeah, it's gonna be.
It's a
this
disk.
It's a what?
Disk.
A disk. Because here's the deal. Okay, I didn't think ahead to what we're doing. Where does this graph keep going? It keeps going up and up and up, yes? So what's this eventually going to do? They're going to touch. Fail me on graph, okay? My assumption, because of all the others we've done, it wasn't going to touch in the range that matters, right? Okay. So, okay. Now, with this so we are touching what we're rotating about. D-I-S-K or D-I-S-C?
GSC.
Oh, it is SC.
You know what? I have both of my notes. That's funny.
I put it K.
I think it's usually seen as a C.
Like a video disc?
Okay. Now,
Like a CD?
okay, guys. Outer, big R, little r.
Big R, outer.
Okay. So as we do this, right? They're asking for outer and inner radius. So the outside edge to what you're rotating about. What was this? This was x equals e to the y, or y equals natural log of x. What are we going to use?
Why?
We're going to have to use the one in terms of x because we're rotating about an x-like axis. And so how's this going to work?
1 minus natural log of x.
1 minus natural log of x.
0.
Little r
1 minus 1.
Yeah.
doesn't exist, right? Because disk method, did we have a little r?
No.
No. Little r was just, or disk method, we just did pi r squared h. We didn't have to think about big R minus little r. So I'm going to say NA.
Danny.
Okay? So,
Not available.
not applicable.
Not available.
Okay, here we go. V equals.
Pi the integral from 0 to 1. Or not 0.
It would be 0.
Then we gotta put another equal.
We have to find where it.
From,
They.
from 1 to, would it be from 1 to infinity?
This makes me rage.
From 1 to bottom of infinity.
It's not infinity, they
No,
do
because
touch.
They cross.
They do cross.
So you got
I said bottom infinity.
Then
So
it's
you
0
gotta
to 1.
set down.
So you guys
Okay.
either.
So, first of all, we are working in terms of x's, yes?
Yes.
So, this point right here,
Oh.
keep in mind, we're not starting at 0. We're starting at 1, because that's what they told me to start. Past that, these do intersect. So we need to know where y equals 1 and y equals ln x intersect. Yes?
Yeah.
Where does this intersect with this? So,
When does ln of x equal 1?
so when does ln x equal 1? Well, if I do a left, right, middle, e to the first equals x. Where do they intersect? At e. So this intersection point that I failed on drawing on my graph,
2.7828.
what?
I just put E.
Can we just keep it 1 to E?
Yeah, you just want e. You would just put e. So this is going to be e comma 1. But we need e. So we're evaluating from 1 to e.
1 minus ln x squared.
1 minus natural log of x squared dx. I know you've already forgotten how to do
It
disk
feels-
method.
It feels wrong.
There's no little r. So, I mean, in your brain, you can say big R squared minus little r squared and say minus 0, but
Do we not have like just an E or oh
Yeah.
okay.
Yeah.
you have an E or you make it E to the first, either or. Okay. Did you put the pi? Did you get the squared?
Pi. That's what.
I'm just going with the two obvious things.
And the day after Pi Day?
Did you leave off the pi or did you forget the squared? Those are the two pieces I'd see you could have done wrong.
Why does mine equal pi? 'Cause I think that's fine. I put X instead of
Okay. It's all calculator button pushing. Obviously, it sounds like we might need a little practice with the calculator button pushing because we're struggling, but I'm ready to do 9.
Mm-hmm.
Are you guys working on 9 and not telling me?
No.
That's what I thought. There's calculator issues out there.
No.
Guys, did you do the extra
Wow.
parentheses with the squared?
Yes.
You need to close the X on
No,
LNX.
I did not.
Yeah.
We're just moving on at this point.
Oh, it's true. There's going to be a parentheses you have to close with the L and X.
There's 3
And then you have to close, and then you had to have started with a
Well, there's
parentheses,
2. Then
and so you have to close the one for the squared.
I didn't close it, and I'm not about to do it again.
Okay. 9. You have the answer if you want to go back and fight later, right?
I was just wondering why I got 3 different info.
Okay. Y equals cube root of x, y equals 0, x equals 8. About the line, x equals 8.
We're in terms of what?
Ooh, we are going back to y's, aren't we?
Why?
Those I chose to.
Okay, y equals cube root of x. We graphed this already this period.
Mm-hmm.
Don't act like we didn't. Y equals cube root of x. We did, because I talked about instead of it being the vertical one, it's the horizontal one.
So now it's
Y equals 0 tells me we're just going to right here. X equals 8 tells me we're going to right here. What were you saying, Kylie?
Y equals X equals Y cubed.
Okay. We are going to have to think about this as x equals y cubed because we are working in terms of y's. I agree. Again, our rotation line is touching, so this is a disk method. Which means, what can I already go ahead and fill in here?
There's no inner radius.
An a dash, I don't know. Leave it blank. Okay. What about big R? Or the only R?
On the curve of the line.
By the way, this is what I'm rotating about, yes? Okay, so what is that? 8 minus what?
Y.
Y cubed.
Y cubed.
Y cubed, because we have to work in terms of y's because we're doing a y-like axis. Okay? We're going to set it up, and then I'm going to move on to the next one. I'm going to give you the answer, and we're going to set up the next one.
The integral 0 to 2.
Oh, yeah, we need bounds, don't we?
2.
It is 2.
Yeah.
Because if X equals 8, then Y has to equal 2.
Okay, so this point is 0, 0. This point is going to be 8, 2, because cube root of 8 is 2. So, yep, and we're in y's. So, yes, 0 to 2. Good call. So, pi times the integral 0 to 2 of,
dy. Oh, sorry.
I got to fill in my other part first. 8 minus y cubed squared dy. If you want to go back and practice later, or if you're ahead of me and already practicing, I have 258.508.
Yes. That's right.
Now,
So wait, the answer is 258.508.
yes.
No, it's just random.
I didn't see it. I had my head down.
And I moved the screen because I was trying to get to my next screen. Okay. Y equals 2 square root of x. Y equals 6. Y-axis about the line, y equals 6. Okay, y equals 2 square root of x. We already graphed this. It's that right now. Keep in mind, we are rotating about the line y equals 6, and y equals 6 is my upper bound. So I'm actually going to draw this graph better than I did that other one. We're going to have an intersection point here, yes? We're going to have an intersection point. Because of we're rotating about that line there.
Natural log of x.
Okay.
2 square root of x.
Except the cube root actually goes on this way.
Cube.
Or which one were you saying?
The natural log of x.
Oh, yeah, except natural log would go down this way. It wouldn't touch. But yeah, so, okay. Got this little guy right here, yes? So, let's see. Method is disk, we're touching again. So no inner radius. What is my main radius?
6.
Oh, you're good. 6 minus 2 square root of x? Because we're supposed to be in terms of x, yes?
Yep.
Okay.
B equals 5 times n equals root of 9.
Okay, let's pause. We are working in terms of x. We know this is 0, 0. I need to know this point. Well, I know it's something comma 6 because it's y equals 6, right?
Yeah.
So my brain is saying 6 equals 2 times the square root of what? 6 divided by 2 is 3. Square root of what is 3? And that is a 9. And we're working in terms of x. So 0 to 9. 6 minus 2 square root of x. Quantity squared dx.
169.646.
Okay.
There you go.
That's it? We're done count?
No.
Yeah.
You're done with new calc lessons. Done with calc, no, we've got another, what, month and a half?
I've been
Yeah,
all that it
basically
is
gonna
of
be
calculus.
And you still have a homework to do. You still have homework to
But
do.
count notes.
Okay. That was our last official calc notes. So,
Realistically, all the stuff we learned.
you have 9 homework questions.
That's it?
3 per page, so 3 pages. Okay, well, I mean, you know, this was 3 problems on 1 page. So, set the graphs up. Pay attention to disk or washer. Pay attention to horizontal or vertical rotation. See what you can do with it. Answer key's already posted, I believe. I believe I posted it this morning because I was trying to be on the ball.
Kylie, can I text you?